Today we're going to talk about probability. Probability is a measure of chance. It's going to give you a numerical measure of the likelihood of an event occurring. It is a number from 0 to 1. Super important. Probability is a number from 0 to 1. A probability of 0 indicates the event will never occur, while a probability of 1 means the event will always occur. The results of a probability experiment are known as outcomes, so super important word, as well as the individual outcomes being investigated are known as events. So probability, the definition, is that it is the number of outcomes in which event A occurs divided by the total number of outcomes in the sample space. And I always say probability is simply what it is that you want divided by the total. So let's take a look at a quick example. In a bag of M&Ms, there's 5 red, 8 yellow, 6 blue, and 10 brown M&Ms. Find the probability of picking one red M&M. So even though the question says, what's the probability of picking one red M&M? What we want are the red M&Ms. And how many are there? There are 5 red. Out of how many in total? You're going to have to add 5 plus 8 plus 6 plus 10. There's a total of 29 M&Ms. So that means that the probability of choosing red is 5 out of 29. The probability of choosing yellow is going to be 8 out of 29. The probability that you pick blue or red, you're going to have to add the blue plus the red, so it's 11 out of 29. And later on, you're going to learn that or in probability means to add, means plus. And then the probability it's not brown, well, if it's not brown, it could be red, yellow, or blue. So you can either add those together, or you can very simply say the probability it's not brown is equal to 1 minus the probability it is brown. And the probability it is brown is 10 out of 29. So basically 19 out of 29. So that's one way you can do the problem. Like I said, the other way is if it's not brown, it could be red, it could be yellow, it could be blue. And if you add those together, it's going to be 19 out of 29. A few things to remember. Probability of an event occurring is a number between 0 and 1 inclusive. If you were to add all of the probabilities in the sample space, it's always going to equal to 1. The probability of an event not occurring is 1 minus the probability it does occur. And we call this the complement. And the way we write it is A with the apostrophe. There are some textbooks that also use A with a little c. But in this case, we're going to see that I'm going to be using the apostrophe for the complement. So the rule is that the probability of A complement, so not A, is 1 minus the probability of A. Think of it in terms of if there is a 40% chance of rain, that means there's a 60% chance it doesn't rain. So basically what you've done is subtracted from 100%. So here it's very similar, except that in terms of percent, it's 100%. Here, probability is out of 1. A few other important definitions. Sample space is basically just the set of every possible outcome of an experiment. Examples are rolling a die. When you roll a die, the sample space is 1, 2, 3, 4, 5, 6. So in a normal die, there are 6 sides. If you have 2 dice, okay, then there's a total of 36 different possible outcomes. And those 36 possible outcomes, I have listed them for you right here. So you can get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and so on until you get to 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Now, there's 36 different possibilities, and a lot of questions in probability deal with rolling 2 dice and getting a particular sum when you roll those 2 dice. So I want you to see that if I were to take, for example, 6 and 1, and I add them together, 6 plus 1 is 7. 5 plus 2 is 7. 4 plus 3 is 7. 3 plus 4 is 7. 2 plus 5 is 7. 1 plus 6 is 7. So all of these diagonally, they add up to 7. Diagonally, they're always going to add up to the same amount as long as you line them up the way I have done for you. So 5, 1, 4, 2, 3, 3, 2, 4, 1, 5, all of those options add up to 6. 4, 1, 3, 2, 2, 3, 1, 4, add up to 5. These will add up to 4. 2, 1, 1, 2 adds up to 3. There's only one way I'm going to get a sum of 2. Then if I keep going here, it's going to add up to 8. These add up to 9. These add up to 10, 11. And there's only one way that it's going to get a sum of 12. And of course, imagine on the exam, if you have to list all 36 possibilities, it's going to take you a very long time. So instead, we have a shortcut, and that shortcut is called a lattice diagram. And what you do on the lattice diagram is that you're going to number all of your choices from the first die going across. Then you're going to number all of the options for the second die coming down. So in this case, it's 1 through 6, 1 through 6. And I'm going to use dots to represent each possible outcome. So these dots represent the same ordered pairs that you have seen on the left-hand side. So all these 36 possibilities basically resemble what you see right here on the left-hand side. So if I were to ask you what's the probability of getting a sum of 7, 6 and 1, 5 and 2, 4 and 3, 3 and 4, 2 and 5, 1 and 6, all of these 6 out of 36 possibilities are going to give me a sum of 7. Other very classic problems in probability are coin tosses. So if you toss a fair coin, you're going to get heads or tails. If you toss one coin twice, or basically toss 2 coins, the sample space becomes heads, 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 tails, tails, heads, tails, tails. And we basically get those possibilities from what's called a tree diagram. Then if you look at part D right here, it says what happens when you toss a coin 3 times, or basically toss 3 coins at a time. I'm going to use a tree diagram to illustrate the sample space. So the first thing is, here's my first coin. I can get either heads or tails. Then comes my second coin, so I branch out. And again, I can get either heads or tails, heads or tails. Then for my third coin or my third toss, which depending on the type of problem, I do it again. Heads, tails, heads, tails, heads, tails, heads, tails. Because when you toss a fair coin, there's 2 possibilities. The total number of possibilities is going to be 2 to the nth power, where n is the number of coins or the number of tosses. So it's either equal to the number of coins or the number of tosses. In this case, because we have 3 coins or 3 tosses, then we have a total of 8 in our sample space, 8 possibilities. And those possibilities are heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and finally tails, tails, tails. So those are the 8 different possibilities, and they basically come, if you follow the tree diagram, you'll be able to tell what all 8 possibilities are. Another very classic problem in probability involves cards. So I want you to take a look at your screen and notice there are 52 cards in total in a deck of cards. Now, we're not including any jokers for those of you who are like, oh, what about the jokers? No. In a regular deck of cards, we're talking about 52 cards. And if you notice, half of the deck is red, the other half is black. At the end, here on the right-hand side, you see jacks, queens, and kings. Those are what are called either face cards or picture cards. So there's a total of 12 picture cards. There are 4 suits. There are the clubs, the diamonds, the hearts, and the spades. There are 13 cards of each suit, so 13 cards of each type. So if we come back to the notes, there are a total of 52 cards in a deck. 26 are red, 26 are black. There are 4 suits, diamonds, clubs, spades, and hearts. There's 13 of each kind. Jack, queens, and kings are considered picture cards. So let's go ahead and take a look at the example. We have 10 numbers written on a separate piece of paper and put into a bag. Sophie puts her hand in the bag and takes out a single card. What's the probability she picks a prime number? So our sample space are all the numbers from 1 to 10. And you might not remember or you might not know, but a prime number is basically a number that's only divisible by 1 in itself. And the first and only even prime number is the number 2. So the prime numbers here are going to be 2, 3, 5, and 7. 9 is not a prime number because 9 is divisible by 3. So that means that we have 1, 2, 3, 4 out of 10, which can be reduced to 2 over 5. And some of you might be thinking, what about 1? How come 1 is not a prime number? By definition, 1 is not a prime number. The first prime number is the number 2. What is the probability she picks a multiple of 5? Multiples of 5 are 5, 10, 15, 20, 25, 30. In this case, there's only 2 of them, so the answer is 2 over 10, which can be reduced to 1/5. What is the probability she picks a 0? If you take a look at the sample space, there's absolutely no 0. So the probability she picks a 0 is 0. It cannot happen. What is the probability she picks a number from 1 to 10? Well, all of the numbers that are in the cards in the bag are actually 1 through 10. So there's a probability of 1 that she is going to pick a number from 1 to 10. That is going to happen for sure. And then what is the probability she does not pick a prime number? Well, that kind of goes back to part A. If 4 of those numbers were prime numbers, that means 6 out of 10 were not. And then 6 out of 10 can be reduced to 3/5. So that's the gist of probability. I hope you found this video useful. This is the beginning of probability. I'm going to continue with other videos so that you can get practice problems on how to handle more questions that are going to be a little bit more challenging on probability.